Today we are going to talk about area, and your sub should have given you notes on area, so you can fill in these notes as we go along. When we get to class next time, I'm going to check to see that your notes are complete and also that your homework is complete. So I'll be looking for two different things next time. Okay, we did area first semester in the right triangle chapter. We did some of the different types of area. So this should not all be new to you. Some of it should be review. Only part of it should be new. So let's see how it goes. So we need to get some area formulas, and I've already got these written down ahead of time, so you need to copy them into your notes. These four we did last time. The area of a triangle is 1/2 base times the height, and I've got a picture of a triangle drawn. The base is at the bottom and the height is drawn in with a dashed line. And remember that in any of these figures, the base and the height always form a right angle. So if you do not have a right angle, you do not have the height and the base. Parallelogram, area equals base times height. And then I drew a parallelogram. You know it's a parallelogram because opposite sides are parallel. Now, with this being a video, it might get a little fast for you to write and keep up, but remember, you can always pause it at any time to catch up with the writing. A rectangle. The area of a rectangle is base times height. And you'll notice that because a rectangle has 4 right angles, the sides are the base and the height because they form right angle. A square. The area of a square is area equals side squared. Because the sides of a square are all the same, if you do base times height, it's really multiplying the same number, so we just say it's side squared. These 4 formulas are new to you this semester. A kite is area equals 1/2 diagonal 1 times diagonal 2. And I color-coded them so you understand that diagonal 1 is the entire diagonal from vertex to vertex, and diagonal 2 is the other diagonal from vertex to vertex, so it's the whole length. It doesn't matter which one is diagonal 1 or diagonal 2. A rhombus has the same formula. Area equals 1/2 diagonal 1 times diagonal 2. And notice on that one I did the diagonal 1 vertical instead of horizontal. It doesn't matter. You just need to know it's the entire length from vertex to vertex. Trapezoid. A trapezoid has 2 formulas. The first one, area equals 1/2 height times the sum of the bases. And the bases, remember, are the parallel sides. Forgot to mark that, so I'll add that into my picture. The height forms a right angle with the base, so you know it's definitely the height. Now, if you look at that formula for the area of a trapezoid, it looks pretty familiar. If I take the height out, you should recognize it as the formula for the length of the midsegment. So another way to rewrite that is the midsegment times the height. Okay, when would you use which one? Well, if you're given the midsegment, use the second one. If you're not, use the first. All right, pause the video as needed to get caught up, and then let's try some examples of finding areas of different quadrilaterals. Example 1. This one's easy. We start as a triangle. Area equals 1/2 the base times the height in a triangle. The base and the height are given to you, you know, because they form a right angle. So I'm going to take 1/2 times the base is 15 times the height is 8. And if you remember from first semester, I didn't divide by 2. I just took one of the numbers and split it in half. That gave me 4. 15 times 4 is 60. And then the label for areas we talked about last time is inches squared. Okay? The reason I just take half one of the numbers like that is when we get into surface area and volume, writing it that way is going to make it a little bit easier for us. So that's the method I'm going with. Let's look at example 2. Example 2, we have a parallelogram. You know that because opposite sides are parallel. So in a parallelogram, the formula is simply area equals base times height. So when I go to plug it in the numbers, be careful because the base is the entire bottom side, which would be 17, and the height is 7. So if I take 17 times 7, I get 119, and then I write my label, meters squared. Example 3. Example 3, we have a rhombus. I know it's a rhombus and not a kite because all 4 sides are congruent. The area of a rhombus equals 1/2 diagonal 1 times diagonal 2. But remember, the diagonals are the entire length. So as I'm plugging this in, diagonal 1, let's say it's the one that's going left and right, so you're thinking of the same number as this one. Okay, so if that is 4, this is 4, so the whole diagonal is 8. Diagonal 2 will make the vertical one. So if the top is part, the bottom is 7, so the whole thing is 14. So I'm going to take half of one of those numbers, and 4 times 14 is 56, so we get an area of 56 centimeters squared. Don't forget to label your answer. I will count off if you don't. Let's look at number 4. Number 4 is a trapezoid. We've got two trapezoid formulas. One uses the mid-segment, one does not. This one clearly does not give you the mid-segment, so we're not going to use it. So we're going to plug in the other numbers. So when I figure that out, I've got area equals 1/2 times the height, which we know is 8. Times the, oh my gosh, I'm having a lot of trouble writing today. Times the sum of the two bases, which would be 11 plus 21. So simplify first. 11 plus 21 gives you 32. Take half of just one of the numbers. 4 times 32 is 128. So we get an area of 128 feet squared. Next example, example 5. Oh, you saw one like this first semester. This is a rectangle. We know the area of a rectangle is base times height. The base and the height always form a right angle. So were you given the base and the height? And the answer is no. No, you were not. And we need to find the base and the height. Well, if we have a triangle and you know 2 of the 3 sides, to find the third side, you're going to use Pythagorean theorem. So we're going to do 8 squared plus the height squared equals 15 squared. You can pause your video and work it out for a second. You should get that the height is 15. So now that I know all the facts, I can plug it in. My base is 8, my height is 15, and then I take 8 times 15 and I get 120, and my label would be yards squared. Number 6, I have a kite. I know it's not a rhombus because not all the sides are congruent. But even though it's not a rhombus, I still have the same formula. The area of a kite equals 1/2 diagonal 1 times diagonal 2. Now, it doesn't matter which one's which. Let's just say diagonal 1 is the horizontal, so that's that whole length, which is 12. Diagonal 2 would be the vertical, which is this whole length, which would be 20. Take half of one of them. Half of 12 is 6, and 6 times 20 gives you 120. Oh, but there's no label. Sometimes that's going to happen. When we have no label, then we're going to put units squared. Let's look at number 7. Number 7 is a right triangle. Well, we've got no problem knowing that the area of the triangle is 1/2 base times height. And we know that the base and the height form a right angle. So these two are going to be my base and the height. So clearly I'm missing some information. What I'm missing is this base. All right. Well, to find the missing side in a right triangle, if we know 2 of the 3 sides, we're going to have to do Pythagorean theorem. So we're going to do 5 squared plus the base squared equals 13 squared. Okay, pause the video and on your own, figure out what the base would be. You should get that the base is 12. All right, so now that I know all the facts, I'm going to plug it in. 1/2 times the base of 12 times the height of 5. Half of 12 is 6, and 6 times 5 is 30. This one doesn't have a label, so we're going to write units squared. Number 8. Number 8 is a triangle. On this triangle, all the angles are marked congruent. We had one like this first semester. We did a handful of these. Either you can mark all the angles congruent or all the sides congruent, but it's the same thing. If all the angles are congruent, you know all the sides are equal. But more importantly, if you know all the angles are equal, 180 divided by 3 is 60. You know all of these angles are 60 degrees. But you do not have a right angle. You are missing the height. So you have to draw in your height to form a right angle. So that is your height. When you do that, that creates a 30, 60, 90. In this 30, 60, 90, 12 is the hypotenuse, so that is 2a. So to solve for the short side, or a, we're going to divide by 2, so the short side is 6. Whatever the short side is, we're going to multiply by radical 3 to get the medium side, so the height is 6 square root 3. Now, when we plug it into our formula, we have 1/2 the base times the height. The base, well, remember the base is the whole thing, and the right is 6, so the left is 6, so the whole base is 12. The height is 6 square root 3. Half of 12 is 6. 6 times 6 would give you 36 square root 3 millimeters squared for your area. Let's look at number 9. Number 9 is a square. And in a square, we know there's only two choices for angle measures. They can either be 45 or they can be 90. So we know that these are 45, 45, 90. So in this 45, 45, 90, you are given the hypotenuse. And the hypotenuse is always a square root 2. So to solve for the side, we're going to divide by radical 2. Use your shortcut. 14 divided by 2 is 7. Add the radical, so all sides are 7 square root 2. The area of a square can be found by taking the sides squared. So I'm going to take 7 square root 2 and square it. When you square a radical, that's really 7 squared times the square root of 2 squared. And remember, 7 squared is 49. The square root of 2 squared is just 2. So that gives you a grand total of 98 millimeters squared for your area. Rolling right along. Number 10, we've got a trapezoid. Well, it doesn't have a mid-segment in it, so we know we have to use the other formula where we've got the bases. So if I think of that formula, that's area equals 1/2 times the height times the sum of the two bases. So let's plug in now what we know. We weren't given the height because we don't have a right angle. We do know, however, the top base is 11. So let's see what else we can figure out. Well, if we don't have a height, we're going to have to draw it in. Oh, looky there. It formed a 30, 60, 90. Isn't that convenient? Okay, so in my 30, 60, 90, 14 is the long side, so that's 2a. So to solve, I'm going to divide by 2. So the short side is 7. Whatever the short side is, I'm going to multiply by radical 3 to get the medium side. So now, magically, I have a height. What I'm still missing, though, is the bottom base. However, because it's an isosceles triangle, it's got to be symmetrical. So if this left side is 7, the right side is 7. And if that top is 11, I know the middle is 11. So the bottom base is 7 plus 11 plus 7. So when we add that all together, we get 25. And that is the second base. All right, let's simplify this equation. So we have 1/2 times 7 square root 3. 11 plus 25 is 36. Half of 36 is 18. And 18 times 7 gives us 126 square root 3 inches squared. All right, next example, number 11. Number 11 is a rhombus. Oh, look at this. It's another 30, 60, 90. I knew it was 30, 60, 90 because in a rhombus the diagonals are perpendicular, so those are 90. So this is the long side. That's 2a. So to solve, we divide by 2, so the short side is 12. Whatever the short side is, we're going to multiply by radical 3 to get the medium side. So the medium side is 12 square root 3. Now be careful when you plug it in to find your area. The area is going to be 1/2 times diagonal 1 times diagonal 2. And remember, the diagonal is the entire length. Let's do this vertical one first. The vertical one is 12 plus 12, which is 24. The horizontal one is 12 radical 3 plus 12 radical 3, which is 24 square root 3. Half of 24 is 12, and then 12 times 24 gives you 288 square root 3 millimeters squared. Example 12. This is a parallelogram. We know it because the opposite sides are parallel. But we do not have a height. I know I don't have a height because I don't have a right angle. And if I don't have a height, I have to draw it in. Oh my goodness, look what happened again. We have a 30, 60, 90. So this is the long side, that's 2a. I divide by 2, so the short side is 7. Whatever the short side is, I'm going to multiply by radical 3 to get the medium side. So now I have the height. So my formula is area equals base times height. And people always want to get this bottom base, want to do 7 plus 24, but that's not right. Because remember, in a parallelogram, opposite sides are congruent. So if the top base is 24, the bottom has to be 24 as well. We're just using that 7 as a guide to get our height. So the base is 24. The height is 7 square root 3. So that's going to give us 24 times 7, which is 168 square root 3 inches squared. Okay, I want you to pause the video now, and I want you to do number 13 on your own. Number 13 is another equilateral, equiangular triangle. We did that in example 8 and first semester, so pause and see if you can figure it out on your own. All right, let's see if you were right. It was equilateral, which told you it was equiangular, so all the angles were 60. 20 was drew in the height, creating a 30, 60, 90. 20 was the long side, you divided by 2. The short side became 10. The medium side was 10 square root 3. That gave you the height. So the area of the triangle is 1/2 times the entire base of 20 times the height of 10 square root 3. Oh, whoops, I didn't finish the problem. Half of 20 is 10, which gives you 100 square root 3 meters squared. All right, we're almost done. Hang in there. Find the area. So, another parallelogram. We know that the area is going to be base times height, but we don't have the height. I know that because where the right angle is my height, but there's no number there. This is not a 30, 60, 90 because there's no angle measures given. But I do know, because it's a right triangle, I can do Pythagorean theorem. So if I do 5 squared plus height squared equals 13 squared, I can figure it out. So pause your video and figure out what the height is. The height comes out to be 12. So when I plug it in, this is going to be the base. Oh, remember the base. It's going to be the same as the top. So it's going to be 18 times the height, which we just figured out is 12. So we get 18 times 12, which is going to be 216, and then label it yards squared. Okay, this one's a little bit different than what we've been doing because you're given the area and then you got to plug in to find something else. This is a kite. The area of a kite is 1/2 diagonal 1 times diagonal 2. You are given the area is 48, so it's going to be 48 equals 1/2. One diagonal you are given is 8, and the other diagonal is x. Half of 8 is 4, so we get 48 equals 4x. We divide by 4, so x equals 12. The label on it, though, is feet because it's a length. It's not area. It's not feet squared. Okay, last example. We've got a trapezoid. We want to find the value of x. Well, the area of a trapezoid is 1/2 times the height times the sum of the two bases. It gave you the area was 136. You do not know the height, that is x, but you know one base is 12, you know the other is 22. So as I plug this into my equation, I get 136 equals 1/2 times x times 34. Take half of what's convenient, that's 17. So I get 136 equals 17x. In your calculator, 136 divided by 17 is 8, so the height is 8, and again, it's just meters because it's a length, not area. Okay, you're finally done. Work on your homework. It's due next class. We'll practice more area and review for your test next class.